So I'm curious to find out if other people feel that way too, and our speakers. He believed in an optimistic and peaceful future, and he thought that humans were taking a step towards from infancy to more adulthood and becoming peaceful and mature. He was the person who introduced me to humanism, so for that I was very grateful. Okay, now you know all about me, and we're going to hear about our speakers. So the information that I have about what we're going to hear is, are human beings by nature aggressive and warlike? If so, what can be done to curtail these instincts? Or do we have a biological imperative towards peace and caring for others? And how can humanist thinking help in preventing conflict? So those are some of the questions we're going to discuss this afternoon. Our first speaker is Dr. P.Z. Myers, who is an American biology professor at the University of Minnesota in Morris, and the author of the science blog Pharyngula. How many of you have actually been reading and following this? I'm sure you'll hear more about it. It's a good blog. He is currently an associate professor of biology at UUM, and he works with zebrafish in the field of evolutionary developmental biology, which is sometimes called Evo-Devo. He is a public critic of intelligent design, ID, and of the creationist movement in general, and is an activist in the American creation evolution controversy, which is a very important, ongoing, bizarre controversy that we have in the United States. So I would like to welcome to the podium P.Z. Myers.
Hello. So let me just hook up the gadgetry here. Yes, okay. Magic. All right, good. Okay, so you'll have to bear with me a little bit. I arrived in Norway by chronosynclastic infundibulum, and so I'm kind of unstuck in time right now, which may mean I'll lapse into incoherence. And you're allowed to come up and slap me and tell me, wake up, wake up. I'll allow that. Now, the original title of my talk was supposed to be Evolution, Conflict, and Religion, and you notice I changed it just on a whim because I thought about it, and I'm not going to say much about religion because religion sucks. So we'll talk about the real stuff. We'll talk about science and evolution. And the message I want to give is that there is a lot of advantage to cooperation that comes out of our biological impulses, and that we shouldn't ignore that. And in particular, one of the things I want to do is I want to combat some myths that go around about evolution. And this, for example, is a set of them. These are comments from creationists in the United States. I know, Norwegians don't have creationists, right? Right. Well, not very many. Okay. Yeah, some. Anyway, what these are all quotes from creationists and religious people who have made these bizarre arguments that, well, if we accept evolution, that means we're nothing but animals. And animals obviously have nothing like empathy and compassion. So if we say that, then all of a sudden our empathy, our social behaviors will disappear. And we'll just be brutes running around raping and robbing and doing all these horrible things that Christians have been doing for centuries. And I want to make a different argument, and that is that no, this is not true. That what we're saying is that things like altruism and cooperation have sound biological basis. That evolution produced these things, and that what we need to do is have a deeper appreciation of the reality of the situation, the processes that have given rise to these phenomena in our own bodies. Now, these are cranks. These are crazy creationists, and I know we don't. They're pointless. We're not going to talk about this. But the thing is that a lot of these attitudes come out of our allies as well. For instance, this is the typical portrait of evolution in people's minds. When I talk to people, yeah, evolution is dinosaurs fighting for dominance and killing each other, and the tough one lives. And you know, we have things like Tennyson in his poem, "Nature red in tooth and claw." That's what everybody thinks of when they think of evolutionary biology. This is what it's all about. And you know, I have a little hobby of watching some of the science documentaries in the U.S. to see exactly what they're saying about evolution, and it's always exactly the same thing. And it drives me a little bit nuts that they'll have a nature documentary and they'll show these animals doing interesting things, and then all of a sudden the music will go ominous, and the narrator will be very, very solemn, and they'll talk about this horrible event that's happening on the screen, which is usually something like an animal killing another one. And this is where they talk about evolution. You know, you can look at meerkats going through social behavior, which is the product of evolution, and they're not going to make a big deal of it. But yeah, you show a tiger chewing up an antelope, that's evolution, that's selection, that's where all the good stuff is happening. And this is not the case. Everything you see in those natural documentaries is about evolution. All life is the product of evolution. And so we ought to be more appreciative of that. Now, I don't want to say that this is not part of evolution. This definitely is. The struggle for survival is part of the story, but it's only part of the story. Now, Darwin himself was aware of this. Darwin made a point of documenting in his big book, Origin of Species, several examples of things where you look at nature and you say, ooh, ick, that's horrible. And you know, his major example was ichneumon wasps, which made him, it's one of the things that made him question the existence of God, is that there are these wasps that have this wonderful lifestyle. What you see there is a wasp, and that big black thing there, that's its ovipositor. And what it does is it flies around, finds a tree, it listens to the tree, and if it hears a grub, a beetle grub working away into the bark, it will pierce the bark with its razor-sharp ovipositor and paralyze the grub and not kill it, lay a bunch of eggs on it, and then the eggs will hatch out and eat the animal alive. Now, oh yeah, you're all saying, oh, that's evolution, all right, yeah. It's brutal and it's cruel and it's horrible. That's got to be evolution. Now, the thing is, though, that when you actually read Darwin, you discover that he's got a much more nuanced view of evolution than people give him credit for. I'm going to show you a brief passage from his book, which is one of my favorite passages from the book. It's only 2 sentences long. Unfortunately, they are Victorian sentences. So he does go on a bit. But this is his capsule summary of the entire story of natural selection. This is his rationale, his logic behind expounding this idea of selection shaping populations over time. And I've highlighted one part in there because that's the relevant part. He's talking about our frequently recurring struggle for existence, but he says, if it vary, however slightly, in any manner profitable to itself. That's the key phrase, is Darwin is not limiting himself. He's not saying only the most savage, brutal, bloody, red and tooth and claws sort of adaptations will get you there. He's saying anything that gives you an advantage is sufficient to explain its persistence in a population. Anything. And what we find when we actually look at evolutionary history is that many of these anythings that appear aren't involved in slaughtering things. And I'm going to give you one example, a beautiful example. This is a barnacle. Now, barnacles are about the most innocuous animal you can imagine, right? What do they do? They're a little bit of a pest in that they'll foul ships and they'll climb up there, they'll settle on piers and rocks and make these little sharp things there. But they form these little colonies, and all the barnacle wants to do with its life is be left alone. It builds a little hard shell around itself, and then what it does, it flicks its feet out, and they wave like little fronds through the ocean, collecting the particles of food and then eating them. That's all it wants to do. Now, selection has been operating on them, and they've gotten very good at that feeding behavior. but they also have another unique attribute which I admire greatly. In this particular diagram, or this photograph here, you see that long thing coming off over here? That's its penis. Many barnacle species have penises that are many body lengths long. Now this is an adaptation, because what the barnacle can now do is, when things are kind of slow and when it's kind of bored with just sitting there eating all day, it just sends its penis out to visit neighboring barnacles. This is beautiful. This is life, okay? And this is something where clearly having a long penis gives you an advantage, and these particular species have thrived because of this particular adaptation. So, this is the first message I want to get across to you is, that there's a lot of myths about evolution that I want to dispel, but this one is an important one, that evolution is not necessarily about killing things. That make love, not war, is the first slogan of evolution. And this is what we're all about in evolutionary history. It doesn't matter how good you are at slaughtering antelopes if you never get laid. Okay? You will not propagate into the next generation. This is the central thing, is these kinds of adaptations. Now, I want to give you another example of an important evolutionary process. And this one is, I don't want to scare you, this is some science. Mitochondria. You all know mitochondria, right? Oh yeah.
Yes.
Okay. One person raised their hand. Mitochondria are pretty cool. If you look at eukaryotic cells, and just to go back to basics right now, everyone in this room, you're all eukaryotes. All right? You all have cells with a true nucleus. You are distinguished from creatures like E. coli, the bacterium, which is a prokaryote. It doesn't have a true nucleus. The other feature of eukaryotes that's really important is we have these little organelles in our cells called mitochondria. And what mitochondria do is that they are specialized parts of our biochemistry. And that's what this little diagram is illustrating here, is that in the cytoplasm of our cells, we have a biochemical process that produces energy called glycolysis. We break down sugar there. In the mitochondria, we have incredibly wonderful complex processes called the Krebs cycle and the electron transport chain. Again, this is a talk for general audiences, so I won't give you a test on this. Lots of complicated, really interesting things going here. But this burns these products down even further and generates much, much more energy. So that's the powerhouse of the cell. This is a little dynamo that you've got in your cells that give you all this wonderful energy that you're using to keep yourself going. And that's keeping me awake right now. Now, the thing is, where did mitochondria come from? And we have a very good answer for where they came from. And they came from, they're the result of cooperation. We've got a pretty good idea of their history. What this is an illustration of the eukaryotic timeline. And what we do is we came from prokaryotic ancestors. Back here on the left, we're talking, 1.5 to 2 billion years ago. So pretty far back there. And the way we got mitochondria was that these prokaryotic ancestors made a partnership with these aerobic heterotrophic prokaryotes. Mitochondria are actually little resident aliens. They are species that we have adopted and incorporated into our cells. And then that species has flourished. And what it's done is it's got rid of most of the stuff that it used to have, and it now specializes in just doing the biochemistry of making energy. And this is great for us because we get energy out of it, lots and lots of energy. And it's great for these bacteria because they have a nice, safe, warm environment in our cells where we take care of all the hard work for them, of all the general stuff of maintaining our existence in the environment. And they are living in a consistent environment where they know what to expect, what to get, and we're feeding them, and then in return they're spewing out all this energy for us. So this is a partnership. Not a competition, cooperation is what led to this. Now, in addition, this diagram there at the top, it shows that there's this other group of organisms, the plants, that have taken it a step further. Not only do they have mitochondria, but they've also adopted a second bacterial species that forms the chloroplast, so they carry out the photosynthetic machinery using these other bacteria inside them. Okay, so this is a cooperative example.